Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you the 21st module titled Frequency Distribution under the paper Tourism and Hospitality Research. The module will cover the following topics. The frequency distribution, uses of frequency distribution, construction of frequency distribution tables, the types of frequency distributions, the frequency distribution graphs and the summary. Dear friends, after the completion of this module, you will be able to understand the purpose behind and use of frequency distribution, know the relevance and applicability of the histograms, the bar charts, apprehend the steps in construction of frequency distribution. Friends, first of all, I would like to give you a brief introduction about the topic. Up to now, we have discussed about the various topics of research in detail, various sampling techniques involved in it, and the various data collection methods that a researcher must know and understand to undertake a research study and obtain fruitful as well as accurate results. In any research, the data collected is generally carrying heavy weightage and sometimes it becomes at most difficult for them to understand it. The essence of larger data is difficult to communicate without any suitable means of summarizing the data. The first topic, frequency distribution. Frequency distribution is a way to present a well-organized data in a proper manner. So, to further examine and understand the construction and applicability or the use of frequency distribution, let us first have something about the term statistics. Statistics is a very useful technique molded in the form of a complete subject that is a byproduct of mathematics. It is a study that basically started in the middle schools and thus became a separate subject to be pursued at the higher levels. It refers to systematic study of collecting, organizing, summarizing, analyzing as well as the interpretation of data for the achievement of research objectives. Its utility can be felt during the estimation or the forecasting of results from the well-organized data. Statistical data includes numerical data, which may be repeated twice or more. The frequency of repeated numbers involves a group of data known as frequency of that variable to which it has been assigned. The frequencies of variables are arranged in a form of a table known as frequency distribution table, and the tabulation of numbers is known as frequency distribution. It is basically defined as the way of tabulating the values consisting of more than one variable. In other words, frequency distribution refers to recording of data elements assigned to each category using the scaling techniques. It is represented in a graphical or a tabular manner, exhibiting the number of data variables within a given class interval. The intervals must be mutually exclusive and exhaustive. Frequency distributions are generally used within a statistical relation. It can be represented in many ways, but broadly illustrated in two ways. First, as a table, and second, in form of graphical representation. A particular grade that defines the measurement scale originally and a record of frequency in each categorical scale. The uses of frequency distribution. First, frequency distribution helps us to analyze and in interpretation of the data. Second, frequency distribution helps us to estimate the frequencies for data. Frequency distribution helps us in displaying the frequency of outcomes in a sample. Let's explain this with the help of an example. Here are the heights in centimeters of 48 students in a class. Pause tablet. Now, this is the data of 48 students' height. This table is denominated as individual series. If the researcher has collected this kind of data, he would not be able to draw any conclusion out of it. However, some of the points that are clear show that no one is shorter than 155 centimeters and no one is taller than 160 centimeters. But if any researcher wants to draw any conclusion about this data set, the question that arises in one's mind is that how might the researcher carry on further? One way to study the data is to identify the minimum and maximum values. It becomes very difficult to do so while going through the table. At the very first stage, the researcher needs to rearrange the above data in some sequence. That is, from the shortest to the tallest. Now, as you can see from this table contains the data of those only 48 students that were present in the previous table. But in this case, it is in the increasing order. So, it becomes easier to analyze. The next is construction of frequency distribution, deciding about the number of classes. Too many or too less number of class intervals may not represent the data set completely. Even it would become more difficult to interpret such frequency distribution. So, how do we do it? First, calculate the range of the data defined by the formula, that is, range is equal to maximum value minus the minimum value, by locating the minimum and the maximum value within the data. Range used to determine the class interval or the class width. Second, the width of the class is denoted by a symbol h defined using the formula range oblique the number of classes. Generally, the class width remains same for all classes. The number of classes that are made taken together must encompass the values starting with the lowest to the highest value. It is generally seen that equal class intervals are mostly preferred in a frequency distribution. But sometimes, according to the situation, inclusion of unequal class interval becomes a necessity to avoid a large number of empty classes. Deciding about the individual class limits and thereby selecting a suitable starting point for the first class is decided arbitrarily. It can be less than or equal to the minimum value. Usually, it is started before a minimum value in such a way that the midpoint, the average of lower and the upper class limits of the first class, is properly placed. Then you have to take an observation and mark a vertical bar for a class it belongs to. Next, find the remaining frequencies, relative as well as cumulative as the case may be, the frequency distribution tables. The researcher can draw a frequency distribution table by recording the heights as well as noting down its frequency in the form of tally marks along with the frequency. With the help of this, the researcher will gain a better understanding of a better sense or the understanding of the nature or the features of the data. Height is the f times a value occurs is shown under the column f. Now in this data of 48 students, it is given the height with the frequencies. We can see the height of 155 centimeters, there are 11 students, 156 centimeters, there are 6 students, 157 centimeters, there are 8 students, and so on till we see that the students with the height of 160 centimeters is 7. The above table is characterized as the discrete series. However, this table might look like a bit clumsy and may not represent or show the results expected. In case of range, that is, the difference between the minimum and maximum values is high. If that would be the case, it would be best suitable to draw a grouped frequency distribution table. There may be a set of rules that might dictate the researcher's choice in the framing of the groups. Like, the number of categories should be kept nearly up to 10. Keep the intervals in this simple calculative format. This can be explained with the help of another example. Let's consider the weight of some people as presented in the table below. Now friends, as you can see, this table is quite lengthy and complex, which still needs to be further precised and refined to make it more appropriate to communicate in order to expect meaningful results so as to enhance its reliability. For example, now in this table you can see the frequencies have been grouped, like 190 to 199 only 1, 180 to 189 0, 170 to 179 1, and so on. This type of series is termed as continuous series. However, there are two changes that draws one's attention, one advantage and one drawback. The further types of frequency distribution. These can be grouped, ungrouped, cumulative, relative, and relative cumulative. Frequency distribution tables, also known as frequency table, is the sum total of the following elements. The classes, classifying the observation into several groups according to the size of values. It is known as the class interval. For example, class interval is shown as 10 to 20. The class limits. The upper and the lower values of each class interval is known as the class limits. For the class 10 to 20, 10 is the lower limit and 20 becomes the upper limit. The mid value. The middlemost value of each class interval is known as the mid value, that is upper plus lower limit divided by 2. For example, in the class of 10 to 20, lower limit is 10 and upper limit is 20. So, the mid value comes out to be 10 plus 20 divided by 2, that is 15 degrees of class interval. The gap between the upper and the lower limit within a class is known as the degree of class interval, that is 10 in this case. Class frequency. It refers to the number of times a certain value occurs. The frequency distribution table refers to an arrangement of the data to make it more meaningful. The data which has been arranged and distributed in such a way is called frequency distribution, and when this is presented in a tabular form are called as frequency distribution table. These can be presented as a frequency table, a histogram, or a bar chart. Both, that is the histogram as well as the bar charts, exhibit a visual display where the y-axis represents the frequency and the x-axis shows the variable to be measured. The following table represents the marks and the frequency of the data. Now, in this table you can see against the number of marks, that is 1, the tally marks are shown as 7 with 4 straight lines then crossed and then 2 straight lines equals to 7. Similarly, when we check the number of marks, that is 4, the tally marks are 4 straight lines and crossed by 1 line, making it total frequency of 5. Then is the frequency distribution again. The numbers represented in the form of tally marks in a table is called the frequency. Relative frequency distribution. It is a kind of distribution in which relative frequencies are entered for each class interval. It is obtained by dividing the frequency obtained per class interval by the sum total of all the frequencies. The cumulative frequency distribution. It is one of the types of frequency distributions which is termed as cumulative frequency distribution. It is obtained for each class interval by the addition of next frequency value to the previous cumulative total. Next is the cumulative relative frequency distribution. It is one more kind of frequency distribution. It is obtained by dividing the cumulative frequencies by the sum total of all the frequencies. Simple frequency distribution. It helps to organize the different set of data in an orderly manner. When the data size is huge, it becomes highly cumbersome to list them separately. A simple frequency distribution shows how frequent a score appears in a set of data defined as the frequency. It is an arrangement of the class intervals and their corresponding frequencies in a table. The frequency table, again, it refers to the number of times a data value occurs. For example, if 5 students have a score of 70 in science, and then the score of 70 would be having a frequency of 5. The frequency of a data value is represented symbolically using an alphabet F grouped distribution table. Here you can see these two tables. In the first table, the class shown is 11 to 15, then 16 to 20, 21 to 25, till 46 to 50. And in table B, it is 10.5 to 15.5, then 15.5 to 20.5, and so on. You can see the difference between these two tables. In the first table, there is a difference of 1 point between two classes, that is 11 to 15, and the next class starts from 16, that is a gap of 1. Whereas in the table B, this gap is removed by increasing it by 0.5. That is, the first class interval ends at 15.5 and the second class interval starts from 15.5 only. Next is the ungrouped frequency distribution. It is a table with a gap of 1 is referred to as ungrouped frequency distribution, as you just saw in table A. It refers to the given set of values arranged in ascending order. This data is of kind which has not been arranged into groups. These are termed as the individual series. When the data is properly arranged, the result is that we get the grouped frequency distribution. Friends, let's now come to the visual presentation of the data, the frequency distribution graphs. There are, as already said, two types of graphs, that is histograms and bar charts. Histograms are the graphs that are represented with the help of continuous form of data consisting of no spaces between the bars, whereas bar charts are drawn using the discrete data types with the spaces or the gaps between the bars. Thus, there are two main points of differences between the two kinds of graphs, that is, the data on which it is to be applied and the way it is to be drawn, that is the spaces between the bars. The frequency distribution graphs exhibits the characteristics of both discrete and continuous type of series. Such graphs are more attention grabbing than a normal tabulation with no arrangement. This facilitates comparison between two or more frequency distributions. The most commonly used frequency distributions are the histograms and the bar charts, along with the frequency polygons. Let's take on the histograms first. A histogram is a set of vertical bars representing the bars having area proportional to its frequencies. At the time of constructing histogram, the variable is taken on the x-axis and the frequencies on the y-axis. The width of the bars plotted on the graph represents the magnitude of the class interval. The bars are drawn without any spaces in between. A histogram represents a continuous curve. In statistics, it refers to graphical representation of the distribution of data. It is an estimate of the probability distribution of a continuous variable. This statistical technique was made known by Carl Pearson. A histogram is graphically represented in the form of adjacent rectangles drawn using separate intervals with an area equal to the gap between the class intervals. The height of a rectangle represents the frequency which is obtained by dividing the frequency obtained by the width of the interval. The categories specified are usually represented in the form of consecutive, non-overlapping intervals of a variable. This can be explained with the help of an example. This example represents data in continuous series with x as the height of the cherry trees in feet and their respective frequencies. Now friends, as you can see on your screen, this table and the graph which shows the cherry trees having a height of 60 to 65 feet are 3 numbers. The cherry trees having a height of 65 to 70 feet again are 3 numbers. The cherry trees having height of 75 to 80 feet are the maximum, that is 10 in number. Now this table is presented in form of the histogram. After the histogram we have the bar charts. Bar charts are much similar to those of histograms. The major points, as mentioned earlier also, the major points of distinction between these two are bar charts are made for discrete series of data, whereas histograms represent the continuous form of data. Secondly, in bar charts there is a space between the bars as the values are independent of each other. But this is not the case in histogram. Thus, a bar chart or a graph is represented using rectangular bars with the lengths in proportion to the values they possess. These bars can be represented either vertically or horizontally. This has been explained with the help of an example. This example is same as was explained in the case of histograms. The table illustrates. As you can see in the table, the height with 60 feet, there are 3 trees. The height with 70 feet, there are 8 trees. The height with the 85 feet, there are 2 trees. And you can see the bar charts. Here you can clearly see the gap between the rectangles. Next is the frequency polygons. A frequency polygon is drawn just like a histogram, except that it is obtained by joining the midpoints of the histogram. It is obtained by joining the midpoints of each of that rectangular bar. When this is done, the dots are connected with lines and the result is a frequency polygon. This can be explained with the same example as was in the case of histogram and bar charts. The table represents the data in discrete series with x as height of the black cherry trees in feet and their frequency. Friends, now you can see on your screen how this frequency polygon looks like. It has been made by joining the midpoints of the histogram. Now we come to the steps followed in the construction of frequency distribution. These are calculation of range. It is calculated by calculating the difference between the largest and the smallest value of data to be arranged, organized and tabulated. Secondly, deciding the appropriate number of classes, which is based on the data that is required to be organized, grouped or tabulated. The number of class intervals is to be decided. There is no fixed rule to decide upon the number of classes that data is to be divided. Thirdly, determine the magnitude of class interval. The class interval is obtained by dividing the range by the number of classes and is denoted by a letter h, that is the class interval size. In case of a fraction, the next upper value is taken as the size of the class interval. Then decide the starting point. The starting point for the creation of class intervals, that is the lower limits of them, are decided upon. For example, 0, 5, 10, 15 and 20 etc. is commonly used. Next is determination of the rest of the class limits. Once the lower limit of a particular class has been decided, then by adding the class size to the lower limit helps in the computation of upper class limit. In the same manner, rest of the class intervals are calculated. Next, distribution of the data into their respective classes. All the observations are entered into their respective classes by drawing the tally marks according to the data size. These bars are counted to determine the frequency for each class. The frequencies obtained for all the classes are noted. The sum total of all the frequencies obtained must be equal to the number of observations available in raw form. Friends, let us now summarize the module. A frequency distribution is defined as the way of tabulating the values consisting of more than one variable. In other words, it refers to recording of data elements assigned to each category using scaling techniques, represented in a graphical or a tabular manner, exhibiting the number of data variables within a given class interval. The intervals must be mutually exclusive and exhaustive. There are many ways of exhibiting the frequency distribution, which includes the histograms, relative frequency histograms, and cumulative frequency distributions. Histograms represent the frequency of all the elements that occur between a certain range of values. When one variable is pretended to be measured on an interval scale and another is dichotomous one, then it is possible to highlight the relationship between the above variables by drawing overlapping frequency distributions. Thank you.